And the answer is P is indeed contained within NP. And the reason is, if the problem that we have can be decided by some polynomial time algorithm S that takes the input, runs in polynomial time, and either says yes or no correctly for that input, then we can design, remember the main thing in the definition of NP is that it has a verification algorithm. So we can define a verification algorithm like this. Define A to take the input and any certificate, and it simply returns S of X. This runs in polynomial time, and it accepts inputs and certificates correctly. So for any input X, there's some certificate that makes it say yes. That is to say, any certificate, because if the answer is yes, it's always going to return yes. And if the answer is no, there's no certificate you can give it that will get it to say anything other than no. And that's, again, because it's ignoring the certificate and actually just giving the answer. So it satisfies the two things that we need for the problem to be in NP. So anything in P is also in NP.